Hi everyone, today we'll be working on solving multi-step equations. When solving multi-step equations, our goal is still to isolate that variable. So here are steps for solving multi-step equations. First, if we have parentheses, we need to distribute. Sometimes we have parentheses on both sides of the equal sign. So we take care of the ones that are on the left side of the equal sign, and then we take care of the ones that are on the right side of the equal sign. The next thing we do is combine like terms. So again, sometimes you're going to have like terms on both sides of the equal sign. So first we take care of anything on the left side, and then we take care of anything that's on the right side. So this part here should be pretty familiar. This is really just simplifying. Okay, so we simplify first, and then we solve. Okay? So step 3 is where we apply our SADMEG. And remember, we talked about that last time. SADMEG is just the order of operations in reverse order. We undo any subtraction and addition, undo any division and multiplication, undo any exponents, and then we undo any grouping symbols. Alright, so here we go. If necessary, we want to leave your answer as a fraction or an improper fraction. Do not convert to a decimal or mixed number. And we've talked about that already this year. Alright, so here are some examples. We're going to solve the equation, and then we're going to write our answer in set builder notation. So remember, we had that in our last set of notes. Alright, so just like I've done before, I draw my line through the equal sign. Alright, so now, the next thing we're going to do is take a look. We have these parentheses. So I want to get rid of those. In order to do that, I need to distribute my 3. Alright, so I'm going to distribute it to both the 4a and to the negative 4a. So remember that, or negative 4. So remember, minus 4 means it's really adding a negative. So if this is subtraction, then that 4 is negative. So when I do that, 3 times 4a is 12a, 3 times negative 4 is negative 12. This negative 12 just comes down. Now we're just down to that two-step equation. Here's my variable that I'm trying to isolate. So the first thing I need to do is get rid of the constant. I really need to get my two constants together, right? But they're on opposite sides of the equal sign. So I want to move this negative 12. To do that, I need to apply the inverse. So the opposite of subtracting is adding. So I'm going to add 12 to both sides. And then we end up with 0 equals 12a. Negative 12 plus 12, remember that's the additive inverse. Additive inverse here to get rid of it, and then we happen to end up with an additive inverse over here as well, equals 0. Alright, so now to isolate that a, to split the coefficient from a, we need to apply the inverse of multiplication, so we're going to divide both sides by 12. Right, and once we do that, we end up with 0 equals a. Alright, so now do we remember what our set builder notation look like? We basically take our answer, 0 equals a, and we're going to flip it around so that the a comes first, so it would be a equals 0. We're going to put it into inside brackets. Now here when it was just done with x's. It really should match the variable though given in the problem. Okay? But we're done, so we're going to circle or box up our answer. Alright, now I want you to try this next one on your own. Alright, watch out because there's just a negative sitting on the outside, so you have to remember what number is actually there. Go ahead and pause the video now. Okay, let's take a look at example 2. Alright, we don't have any parentheses here. We don't have anything to distribute. So the next thing we want to look for are like terms. So on the left side of my equal sign, I have like terms. I have 12n and I have that negative 5n. So we need to take care of those first. So 12n minus 5n is going to give us 7n. And then we bring down the minus 4, and then we bring down the 10 on this side. Now we're back down to just a two-step equation. We need to isolate that n. But first, we need to get this 4 away from it. So since it's minus 4, we're going to add 4 to both sides. 10 plus 4 gives us 14. Right? The additive inverse cancels each other out, so we're just left with 7n. Now we need to undo that multiplication. We do that by dividing both sides by 7, and then we're left with n equals 2. All right, now let's take our answer and put it into set builder notation. And there we have it. And then since that's it, we're going to box up our answer, and then we're done with that problem. All right, let's come to the next page. All right, same type of problem. So I want you to give this one a try on your own. Go ahead and pause the video now. Okay. All right, now let's put it all together. All right, we're going to have to do some distributing, and we're going to have to do some combining like terms. And then we're going to make sure we write our answer in set builder notation. So again, draw my line. I see parentheses, so I'm going to take care of that first. I'm going to distribute my 4 to that negative b. And it's really like saying a negative 1b. And then I'm going to distribute my 4 over to that positive 3. 2b comes down, so we're going to end up with 2b minus 4b plus 12. And then we bring down our negative 5. All right, now we have to look for like terms. 2b minus 4b, they happen to be right next to each other, gives us negative 2b. So now we're going to have negative 2b plus 12 equals negative 5. So again, that negative 5 just comes down. Now we're down to that nice two-step equation. We're trying to isolate the b. Before we can do that, we have to undo our addition. So we're going to subtract 12 from both sides. We end up with 17 on the right side. Additive inverse right here, so they cancel out. We're left with negative 2b equals 17. Next, to isolate the b, we're going to divide both sides by negative 2. All right, so this is a case where 17 divided by 2 is going to give us a decimal. We do not want a decimal, so we need to make sure it's simplified. I have 2 negatives, so 2 negatives make a positive. So right away I know my answer has to be positive. And then I check, is there anything I can divide into 17 and 2? There's not. So my answer is just going to be b equals positive 17 over 2. And then put that into set builder notation. Done. Put a box or a circle around your answer. Okay, I'd like you to try this next one on your own. Go ahead and pause the video. Okay, now we're going to take a look at proportion equations, and we're going to see what happens, or how do we solve an equation that's built into a proportion. We're going to do a quick review of just a basic proportion. All right, so remember, when we are trying to figure out this missing value here, we want to cross multiply. So I'm going to multiply my 4 and my x together, and then I'm going to multiply my 3 and my 16 together. So just like that. Doesn't matter which one you do first, and you may end up having a preference. My personal preference is to do whatever diagonal has the x in it first. All right, so now we can simplify both sides. So I get 4x is equal to 48. To isolate that x, I'm going to divide both sides by 4. And then we end up with x equals 12. Now we can go ahead and put that into set builder notation. And we're done. Put a box around our answer. All right, let's go to the next page. And this time I want you to try this one on your own. Nice little quick review on solving proportions. Go ahead and pause the video. Okay, now we're going to add a little bit to it. So we've just reviewed how to solve a basic proportion. Now we're going to look to see what happens when we have multiple terms in one spot of our proportion. So in this case, instead of just having x, I have x minus 6. All right, so here's how we're going to take care of that. Whenever I see multiple terms in one spot, I'm going to automatically put some parentheses around that. So I'm going to do this. Let's see. I'm going to put a parenthesis in here. And then I'm going to come over to this side, and I'm going to close my parentheses. All right, so now that's going to help me remember that when I am ready to cross multiply, right, I have to do not just 5 times x, but it has to be 5 times this whole thing. So when I do this, I'm going to multiply. Whoop, that was not the greatest. All right, I'm going to do that 5 times x minus 6. And then I can also do the 6 times 10. All right, so let's get that typed in. So here's what we have so far. We have 5 times x minus 6 is going to equal the 6 times 10. So now we're going to go down to our next line, and we're going to distribute that 5. So we end up with 5x minus 30 is going to equal 60. All right, so now we've got that nice equation to solve. I'm going to draw my line through the equal sign. And now we can go ahead and start solving. So I have to isolate that x, but in order to, before I can undo that multiplication, I need to undo this addition. So I'm going to add 30 to this side, and then I'm going to go ahead and add 30 to this side. All right, so now I tend to like to draw lines after I do a step. So I'm just going to draw my line in. All right, and now here's my additive inverse. They cancel each other out. So I'm left with just the 5x on this side. And that's going to equal, whoops, not plus, equal 60 plus 30, which gives us 90. All right, now our last step is we're going to divide both sides by 5. So I'm going to divide this side by 5, and then I'm going to divide this side by 5. All right, so divide this side by 5, divide this side by 5. Okay, and then we end up with, let's see, we end up with x equals 18. So now I'm going to put that into set builder notation because we should get in the habit of always doing that. So I get x, I'm going to put my line in a second, such that x equals 18. Close our bracket, and now I'm going to go in and put my line in. There we have it. Okay, so there's my answer. And since I'm done, now I'm going to circle my answer. There we go. Okay, so our key concept here is when we're cross multiplying, we don't want to forget to distribute when necessary. So don't forget to distribute when necessary. Okay, so now we've got one more, just like the one we did. Okay, I want you to go ahead and try this one on your own. And then this is the end of our video. So you can stop now and complete this problem. I'll see you in class next time.